Okay, great. So we're going to start. My name is Pascal Menezes. I'm a principal programming manager at Microsoft and for Lync and Skype. So basically, I'm doing most of the networking programs, Wi-Fi, SDN, software-defined networks. And let me introduce Manfred.
Sure. I'm Manfred Arndt. I'm the chief technologist for UC for HP Networking. I'm part of our advanced technology group, which is our CTO office. So I'm driving kind of our strategy and vision of how to support real-time multimedia across the entire network portfolio and across HP products. And I've been working very closely with Microsoft since 2008, around prior to when it was still OCS days. And I've been working very closely with Pascal on what we're going to talk about here about software-defined networking.
So how many people here, raise your hands, heard software-defined networks? Mostly everybody. How many people here are any customers, enterprise customers, operators? Oh, okay, a few. That's good. The rest all vendors? I would say mostly vendors. Okay. So we're going to cover basically automating quality of service. Now, this is not just a futuristic potential. This is actually working, shipping demo. Not say demo, proof of concept that HP is. Are you showing in your booth?
We're only showing the video in our booth. Unfortunately, we had a conflict with resources, but it's something we've taken to at least 10 events worldwide, and it's going to be at Enterprise Connect as well. So
they can see it in live.
It's okay. Live. And we've gotten such, when we did the first demo last April at ONS, we got such a strong response. We're productizing it, so it's in development right now, and we're going to be introducing it pretty soon.
So let's just get started here. So basically, we'll cover through the agenda. A little bit of overview of SDN. There was a session this morning. I'm not sure if any of you guys attended that. Did anybody attend the session this morning? Oh, quite a few. So I'll just run through that really fast. And then basically, we'll get into exactly quality of service. How do we automate quality of service? Much more technical, much more detailed. Manfred will take through a lot of that stuff. And basically, the path to SDN. How do you go from today's networks to finally a full SDN-blown network? So as you guys know, some of you guys this morning, basically the bottom line is that most customers tell us there's a problem with Lync, and really when we look deep into it, it's normally a problem with the network, 60 to 80%. And so the bottom line is it has poor visibility into the network, and at the same time, basically, what we find is the majority of the issues, I wouldn't say all of them, of the networking issues, are quality of service related. The provisioning of quality of service is expensive, it's complex, and maintaining that end-to-end all the time is hard. So you can get it right, lock it in, and then you get configuration drift. And a lot of times, even though you do all the right markings on the endpoints and the servers, somewhere in the network, they strip it off or they remark it, and then you don't get that full experience. So that's a key point I want to bring up. So anything else you want to cover?
Well, the one part is it's complex to get right. You think you've got it set up right, but the only way to really know it's not working is when you've got congestion in your network. So it's kind of like trying to prove aliens don't exist. It's hard until you actually have a problem. And then once it's there, it's a very intermittent problem. So trying to identify it and fix it is very hard. It's not like a connectivity issue. Those are easy to fix. This is the kind of problem you think you've got it working, and only intermittently does it cause problems.
Yeah, and actually, very good point. I just actually was on a troubleshooting exercise a couple of weeks. People came to me and said, look, we were having this problem with this certain system we've been using and prototyping, and we don't know. It's something's right and wrong. After deep investigations, the QoS policy was not being deployed for that OU, which they were in. So, very, very, this is very technical, sensitive, lots of moving parts to get right. And that was a simple problem, actually. And it took, weeks to figure that out. So a very tough to problem, and that's what we're trying to solve here. The next thing I want to talk about is, if you've seen these slides, is basically our vision of software-defined networks is making applications work and better together with the network. And what we mean by that is the actual application software defining the network. Software defining the network. So we think that's really what the vision's all about. And I'm sure from HP that they have a little bit of a tweak to that, and we'll go through that. But we want to simplify, the policy, the deployment, the configuration. We want to automate the process, just like you have today with VMs. You have that today, for example, in cloud data centers. You do a live migration, you move a VM, and then through SDN, the network just adapts to that move. I mean, so that's where it all started, that kind of concepts. But there's many scenarios, and we're going to show about, including this one around quality of service. There are other sessions on diagnostics and on Wi-Fi. This one's going to focus on the scenario on quality of service.
And let me just add a little bit to it.
Sure.
It's kind of the difference between guessing and knowing. Today, the network is trying to, on a box-by-box basis, inspect traffic and try to defer. I think this is the type of application. But as the earlier slide showed, more and more traffic is being encrypted, and more traffic is trying to hide itself from the network for security reasons or other reasons. So how does the network know? Right? Cisco prides itself with putting a lot of that deep packet inspection on a box-by-box basis, and that's where a lot of the problems come about. With SDN, we can stop guessing. We know for a fact not just that this is voice or video, but how much bandwidth you're trying to use. And there's a lot more powerful capabilities that this allows us to derive going forward.
So if you think about it, internet networking, this is my 30th year in internet networking, and I actually did a lot of the policies in Canada way back in the 80s on BGP and everything. And if you look at the slide right here, you see that basically, we're still in the model of, we're still in 30-plus-year-old internet networking technology of OSPF, BGP. It's still, nothing's changed. We tried to do constraint-based routing. That never really happened. So basically, we still have this model of a distributed control plane. Every node talks to each other through this protocol that's 30-plus years old, right? Trying to coordinate, how to forward a packet, and it's still based on some shortest path algorithm, and there's no concept if the link's congested, what to do with it, or any of that kind of stuff. They have no constraint-based routing. It doesn't even exist. We tried to do it with MPLS for traffic engineering to an aggregate basis, and it's still not real time. So basically,
we've tried RSVP where we had the endpoints trying to talk to the network, but the problem with that kind of approach is twofold. One is you trust the endpoints. When you trust the user, I liken it to what happens in the carpool lane. People put dummies in the carpool lane because if they put a dummy in there, all of a sudden they get to go drive faster, and people like to get that better quality of service. So with RSVP, as soon as you have to trust the endpoint, where's the trust in there? And then the bigger problem is the solution only worked if every box along the way was RSVP enabled. So it's kind of like a chicken and egg. When was that going to happen?
Yeah, let me try this clicker here. So the next thing is what you find is that what we've done is we've put in the network, very complex technologies to do all this deep packet inspection, to actually look at and try to do these services like IPS, IDS, like firewall. All these very expensive boxes are put in to run network services. And they are, by definition, also distributed in some form or manner. And so, and this is expensive. It's expensive to operate. There's many touch points. It doesn't behave as a system most of the time. And so this is internet networking today. Really what we're trying to get to is a model. Now, internet networking back then was we had processors that were slow, memory was expensive. I mean, all the things that, we had to deal with. That's why we did what we did. But today, we have very, very fast processors, huge amount of memory capacities. And so the bottom line is the software-defined networks today is the idea of there's a centralized intelligence, much like what SS7 did with PSTN, that there's a centralized intelligence that where the control plane and the diagnostic services, or these network services are kind of where all the intelligence is. And then basically what you get is you get this kind of like programming of these network elements that run these flow tables, and I don't know if I think there's a diagram that talks more about how that works. And that policy is being driven by this protocol OpenFlow as an example that's the de facto standard for this southbound interface. And this OpenFlow can actually program at very rapid rates. So the idea of a controller has to send many, many commands, unlike CLI, which was not designed for this kind of stuff, or SNMP, this OpenFlow is designed almost like instruction sets and CPUs. It can program it really fast, and it's done through the network. So this is really what's going on. There is another extension to this model of software-defined networks that says applications are actually the ones that actually talk down through what we call a northbound interface. And I'll talk a little bit more. If you were at the session this morning, I talked about the standardization from ONF and UCI Forum. This northbound interface is where applications can talk to it, and we'll get more details about this, and program the controller off the intelligence it wants. So for example, in the UC&C thing, it's telling it about flows and quality of flows. But there could be other kinds of applications doing, like, for example, cloud orchestration is another example. So this is what we call the application layer. And we're specifically talking about end-user applications talking to network. So there could be many different applications. We're talking about an end-user app like UC, like Lync, like Skype. Okay? So the bottom line is, and you saw this morning, you saw the slide, is, a nice quote here is the network will be able to adapt to changing application requirements. And this is very key. As the application can talk to the network adapts itself. It sets us up correctly. In this case, quality of the service is the example we're going to show you. But it can do many more things, even including diagnose itself, reroute itself, traffic engineer itself, heal itself. These are the things we're going after. And this is not futuristic. This is actually demonstratable products and technologies, and we're trying to standardize it. Anything else you want to cover?
Well, just to highlight, today where we're doing the API, the application's talking to the network, but our vision is that the network can also talk back to the application to provide even further intelligence. So maybe when there's congestion, we can even start doing things like, hey, start compressing the codec. So things like call admission control today are so complex, the majority of customers I know, whether it's a Cisco Call Manager, whether it's an Avaya, whether it's Lync, it's so complex. And you get it right, all you need to do is change one thing on one WAN link, and the model's already wrong. So this is kind of a promise going forward in some additional activities we're driving, how even things like load balancing, policy-based routing, call admission control can be solved in an SDN model and automated in a manner that is exceedingly difficult and complex today.
Okay, thanks. Memphis, do you want to talk about that?
Sure. Let me have a clicker. So, SDN can be different things to different people. There's SDN that's kind of a virtual SDN. There's SDN that's the physical SDN. But for a lot of people in the industry, SDN is still focused in the data center. We believe SDN, HP really believes SDN is important from both the data center, where the applications reside, through the core of the network, to the campus and branch, where the end users consume the application. And so we've been driving SDN since we were actually working with OpenFlow before it was called OpenFlow. Back in 2007, we started working with Stanford University. We're kind of dabbling with it. We didn't kind of know what we could do with it, but we thought it was pretty cool technology. Because of that, we have it now embedded in the ASICs in most of the products. We've got 25 million ports already deployed, so it's not really science fair. We have a large number of our customers who have it already ready, just don't know about it. And what we do is with the controller can use OpenFlow via the southbound API to control the switches and do things in a standardized manner. And as more and more vendors embrace it, this now will work across multi-vendor. So you'd be able to take any OpenFlow switch and be able to program it. Hopefully use our controller, but if you prefer another controller and has the right functionality, you should be able to use that as well. And then the northbound API will talk to the SDN application, and we want to standardize that as well. So as an example, Pascal, myself, and HP, we're taking this both to the ONF, where we recently got a new working group started, and we're going to be driving the standardization. Sarah Raz, our colleague of mine in Advanced Technology Group, is chairing that as kind of the overseeing. It's more kind of the container of how do we create a messaging API. Pascal is driving the user work group, and that's going to be focused on what do we do in the campus and branch, so he's the vice chair of that. We actually have another colleague who recently joined us from Plexi. He's driving what's in the data center. So we believe there's a lot of momentum driving that standardization activity. So what we're doing today with Lync, our vision is to make sure we can drive that across a larger ecosystem of applications as well, because it benefits much more than just Lync. But the important thing is, the different layers. We've got the infrastructure layer, the control layer, and the application layer, and we're going to drill down into that a little more. So Pascal?
Yeah. So I know some of these slides are duplicates. We will get into completely different slides in much, much more technical detail, so just bear with us. For people who have not seen this, I want to make sure they get a good view. So as you saw, the other slides show it more on a very high-level view. In reality, this is how it's kind of getting implemented. And what you get is, where's the button for the laser? Oh, is that
the top red button should be at that one right there.
Okay, good. So what you get is, on the controller, today, if you get a controller, you'll get this low-level functions like flow programming, path computation, inventory topology, and then they talk southbound open flow to these network elements. And that's about, that's kind of like a standard controller implementation like Open Daylight, Open Floodlight, Open Contrail. But really what's happening is the intelligence sits up here. This intelligent layer, and what we'll talk about is QoS specifically, has an analytical function. It's kind of like network service function. In a model of SDN, they call that the application layer. But in reality, from an end user app, this is not the application layer. This is a network service app. It's not an end user app. And so we have different layers of northbound API. This API, northbound interface, is for programming for this QoS app to program and use these low-level functions, where another app will probably use the exact same interface for these low-level functions. But the abstraction layer we care about is up in the UC side, is just a different northbound interface that gives different information. So this is about session information. This is about flow programming, topology, inventory. And so the logic in there calls all these different interfaces to figure out what to do. And, Manfred will go to details of this. But what I want to leave you with is that this is really what's going on. There's more than just that simple layer I showed you. There's this network service layer that is actually adding the intelligence, working with an end user app. They can do some pretty powerful stuff. And so what you get is, let me try it this way. Controllers are moving to have more and more intelligence, where before they were just doing this, they're now incorporating these network service apps. It doesn't mean they have to be in the box. This is a decomposed model where you can run them anywhere. Controller could run here, and the app can run somewhere else. But they behave logically as one. And they'll probably controller manufacturers will ship these applications very much as part of, maybe an add-on module you pay for, and so on. And basically, they'll keep building this intelligence, this analytical layer on top. Because this is all kind of open source. Everybody's kind of doing this kind of stuff. It's not something they're going to make a lot of money and differentiate yourself. This is where it's really starting to happen. And this is called an SDN application. And this above it is now an application, an end user app that's SDN aware. And it's talking again to the network source there. So I've kind of overdone. Anything else?
And that was a good breakdown, because part of it is application developers don't want to go to the level of detail of what does the topology mean, what do the individual links mean. They want to apply a higher level policy that says, I want a higher quality level of service. I need this much bandwidth, and the analytics in that app can then translate that to lower level logic and make that programming much, much easier. The other thing that this is going to allow us to do is provide much, much more rapid innovation. In the past, whenever we want to try to add new functionality to the network, we first had to get it into the switches. We had to get it across all the different platforms you had out there. You might have different models of switches, different revisions of switches. And these switches, because of cost reasons, never had enough memory. They never had enough CPU cycles. And the ASICs often didn't have enough of the functionality. So it would take years to get this kind of functionality out there in new products, let alone even more years to get it into different customers. But what we're doing here is creating more primitives that are embedded into the ASIC, more functionality into the ASIC, but we're letting the software now be developed in a true software environment and allows much more rapid innovation. So I see so much more excitement in the networking industry in the last year than I've seen in the last 15 years, and how much more, once we get that foundational element down here built, we're going to be able to not necessarily totally commoditize the network, but we'll be able to unlock functionality that's built into the ASIC. Some of these ASICs have been shipping for years. People couldn't take advantage of that because it was so hard to configure and do these policies, especially in a CLI on a box-by-box basis.
So we're going to focus in this session about the QoS, and we're going to get in more details. I think the next session is about the API, and I'll go through really fast. Some people have already seen it, and so I don't want to spend a lot of energy on it. The bottom line is the current API today, we're shipping it. This is how it behaves. These are the two main abstracts or the constructs of the API, just to kind of close it off and make sure everybody understands it, because as we get in the QoS, this will all be part of the QoS scenarios, and I'll show you the details. So basically today, signaling starts up, accepts signaling, goes to our proxy servers, our front ends. It finds the destination endpoints, and then media starts up, right? And as soon as media starts up, as early media starts up, we send an event from our API, our SDN API, and we send it to our network controller, or in this case, an SDN controller. And then we send a bunch of information. It's the start of a session. Here's the 5-tuple IP address, port numbers being used. Remember, because this session is all encrypted, so there's no way of sniffing all this unless you use heuristics. But bottom line is that this is all part of that API, and then also gives us voice, video, data, kind of bandwidth, minimum, maximum bandwidth, all kinds of really cool stuff, including potentially the SIP URIs involved. So very, very good stuff. So this is what we call the dialogue event. It's a web service using a RESTful architecture. And then at that point, from that event, programming can start from that analytical module working with the controllers. I don't show the analytical module in here. And then the other event is this quality update event. When there's actual media flowing, things are great, but as soon as there's a problem with the media, we'll send out an event. And this will be like, okay, we got a quality problem, and we're getting jitter or packet loss or delay or MOS score too low, whatever. And this is today. It's after the call. We're about to release one that's during the call, which is really powerful. So at this point, now the network can adapt itself in real time. And so again, when that event comes out, the network controller with the analytical logic or the network service logic can actually do cross provisioning or traffic engineering, whatever the issue is that's affecting this. Again, where we are today, ships on 2010, ships on 2013. It's an out-of-band API. You download it from the website. It's called Lync SDN API space, and you can just bing that, and you will find that it's downloadable for free. You install it on the front ends, and there's an SDN manager component that you build out. It runs separately from the front ends, or it could run on the front ends, or it can run on its own server, or it's just like a role, and they all work together. The session prior, which is recorded, has a lot of details about this you can get from. So I don't want to spend a lot of energy on this. And we're continuing to advance the API with partners. So like Manfred talked about, getting information from the network is the next part. Right now, we're just giving information about the application. But can the application take things from the network? That could be very cool. For example, even setting QoS, you'll see in our use cases, when we set the QoS, do we know we're actually getting the QoS back to what we set? So that's an example of giving back. So let me turn it over to Manfred, and he'll cover the QoS section.
Well, together we'll cover it. So, real-time media is a very different application than typical TCP traffic. It has very strict requirements on both latency, both on packet loss, both on jitter, and so you do need to treat it a little bit different. Now, modern applications of Lync have a very robust codec, and the way I liken it, like a four-wheel drive vehicle. So imagine you have a really good Jeep with a four-wheel drive vehicle, but why don't you take that off-road all the time, right? It works way better off-road than, say, Prius, but your gas mileage and your enjoyment isn't going to be as good as being on the freeway. So when you can be on an engineered network, when you can be on an MPLS network, you're going to have a quality experience 100% of the time, versus when you're running it, say, over an internet or an unmanaged network, it might be 80% of the time. So, while being able to run over the internet is powerful and compelling, you want to engineer your network as well as you can, especially when you're trying to do a PBX replacement. So the bandwidth requirements for voice can depend on whether you're doing compressed or uncompressed. So it's typically 100 kilobits for uncompressed, 30 kilobits for compressed. Video can be much more. So the point being is we're just starting to scratch the surface with video. And there's a lot of customers who just going down the voice enterprise path, they're still a little nervous. What does video mean to my network? So how can I manage it? How can I control it? This API, we believe, is also going to be very beneficial in the video world to give you more visibility and let you control what's going on there. The important thing is packet loss is the worst thing that you can have because there's no ability to retransmit the real-time traffic. So, you want to minimize the packet loss, and then you want to minimize the jitter and delay as much as possible. What's important is when you're mapping to QoS, there is no complete right or wrong way. I mean, different people have different opinions, but these are kind of recommendations from the IETF, and these are recommendations from HP Network, and these align pretty much very closely with the Lync recommendations, except for maybe the desktop sharing or TFTP slightly different. But the industry is pretty much agreed on for the majority of use cases, you're going to want your voice to be the highest application. You typically have network control a little higher than that so you can reconfigure the network if something's wrong with it. But from an application standpoint, voice is the highest, and that's expedited forwarding. Interactive video, and when I say interactive, that's not things like YouTube video. Streaming video that can buffer doesn't need QoS. Okay? It just needs high bandwidth. Real-time interactive cannot be retransmitted, and if there's a packet loss, it turns into, instead of just buffering, which you see, which is annoying, it turns into, completely garbled and unintelligent conversation and makes people stop using video. So if once people have a bad experience with video 2 or 3 times, they're going to stop using it. The signaling is, you want to see, the industry is pretty much well standardized on that as well. The main thing is you're just going to want to not have packet loss because it's often run as, it can be run as UDP, but you want it to be responsive and not take a long time. The other ones, these two can differ a little bit, whether you're running CS2 or AF21 isn't that big of a deal. The most important thing is, do you have the order of the applications relatively correct, and do you have it correct end-to-end? That's the most important thing. What you don't want to be doing is having one marking on one switch and then having it be ignored on another switch. So QoS is only as good as the weakest link. That's why it's important for us to automate it to make sure we don't have any gaps through our network. Here's the guidelines that Lync recommends. If you notice, the first 3 are exactly the same recommendations of what our guidelines are. And these 2 are slightly different, but they really effectively map almost to the same DSCP code point. So whether you use AF21 or CS2 is pretty much about the same thing.
So what we're going to show you is that today in Lync, you have to actually deploy QoS. You actually have to intentionally take it out of the box, configure all Lync, and then you have to sit and understand how to deploy QoS because it's not on by default. And so not only you have to understand how to turn Lync on for QoS on all the endpoints and servers, but then you have to make sure end-to-end in the network, those markings that we talked about are actually hop by hop in every router, every switch, every Wi-Fi unit, it is a very expensive process to get correct end-to-end. And then you have to maintain it every day because you get configuration drift, things come in and out. So this is why quality of service is an expensive process. And if we don't have quality of service, for consumer video like Skype and Google Hangout and all the others, it's okay because they don't really pay for it. But on the enterprise, the end users expect the experience of the good old PSTN telephone to be very reliable, high quality, always there, highly available. All the things that they're used to has to have that same behavior. Yet we're running over an IP network, and the IP network has to be right. So that's why QoS is so important.
And I've actually run into a couple accounts where the pilot was going really well. And remember, Lync appeals to the application group, doesn't appeal to the networking group. The Cisco Call Manager appeals to the networking group. And I've seen cases where there's a little bit of political battle going on, and they intentionally made sure that Cisco Call Manager got good QoS, but they intentionally made sure Lync did not get good QoS. And the 2 groups weren't really talking. And the pilot was going really well, and it should go well. When you're only having a handful of calls, there's no issue. But Lync adoption always grows, and Lync adoption, once it grows, tends to grow like wildfire. And as the adoption grew, call quality issues started to happen. And guess what? The network engineer was smiling, goes to his boss, and I told you, hey, Lync wasn't ready for prime time. It's not running well. See, I told you the QoS issues, but the reality, he intentionally made sure he didn't even have the right policy set.
And actually, that's a good point. I've had a lot of customers start with IM and presence with Lync. And what you'll see in some slides here, IM presence doesn't need any quality of service. But then they try turning on voice and video and spots. And what happens is the network is designed to not obey any of the markings. So if it does get marked and you do turn it on, then it would strip it off in the network.
And we'll cover that in more detail in a couple later slides.
These are very common problems. It's epidemic, actually. So I want to do a little QoS tutorial. We talked a little about disk serve code points and all that, but I want to show about specifically the EF queue, which is the voice queue we talk about, why it's so sensitive. So how many people are really kind of like a QoS expert here? One? Okay.
Okay, come on up here because we don't know what these slides do, okay?
So this is basically how every network element in a network kind of runs. You have these different classes of queues, you have your output link, you have a scheduler, weighted round robin, weighted for queuing, all the stuff you heard about from Cisco. And basically, you can put this committed rate for every class, right? And so basically, you just don't put this is on mainly routing technology. You take your link, and whatever bandwidth is available, you take your class and you give it a certain amount of minimum bandwidth that's guaranteed. So for like EFQ, you give it, like maybe 20% of the output. And so you don't starve, this doesn't starve out everything else. So this is a common deployment practice model. What you'll notice is that on best effort, you got this buffer, and it just drains it out. And certainly these are contending. The scheduler decides which class runs, for the queuing to queue out to the link. And you have these drop zones. This is why they call them, AF, 21, 22, 23. These different drop zones on where you'll drop packets. And what happens is, why I'm showing all of this is that basically there's different classes of service. They all have different behavior types. But there's one specific behavior type that's really important, is this called EF. This EF has to emulate a wire because you don't want jitter, you don't want buffer delay. You want to emulate like a wire. So the minimum you want is like a 1-packet buffer, and that's it. While these ones have different buffering and different drop zones. So if you have to drop a packet, depending on your drop zone, you'll drop in that zone. And you can buffer more packets in, so you'll get more jitter, more delay. But that's OK because they're not so real-time sensitive like voice. But in the EFQ, like I said, it's a 1-packet buffer. So you got to watch what happens here. What happens in every node is if the ingress is less than the egress. This is the key point. Node hop by hop by hop. If the ingress is less than the egress, you're OK. No packets are going to drop. But remember, that's not only sustainable, that's even during burst times, right? But what happens normally is you get people using the voice queue, the EFQ, and basically, I'm going to get to the reason why this is important. What happens is sessions are running, and all of a sudden the next guy comes on and starts a voice session, and all of a sudden packets start dropping. But they don't drop from the last guy who came on. They drop randomly. So everybody gets affected. And so all of the voice queues on that node, potentially who got dropped and packets get affected. So even the call, 5 calls before ahead of the last guy coming on can be affected. This is a serious problem. So a decade ago, the internet networking guys, Cisco, HP, had how to solve the problem. And I'll let Manfred talk because he's the HP networking expert here.
Sure. So first I want to kind of talk about the today's IP phone model because the people that think you really don't need QoS really haven't gone into the soft phone world. With the IP phone for the last 10 or so, 15 years, things have worked really, really well. And the reason they've worked well is the phone will auto-configure to the switch. I co-author LLDB Med, so most of the phones nowadays, including the Lync phones, the Polycom phones, the HP phones, if you plug them in, they automatically get the right VLAN. They automatically get the right QoS policy, and they don't run anything else. They only run voice, and they're trusted. Okay? If you feel like it, you can give the VLAN the QoS policy, but our recommendation is you honor the DSCP marking from the phone. Okay? Life has been good. There hasn't been any problem on it because the phone is trusted. The phone can't download any other applications. The phone can't do anything. The user can't go and reconfigure it. Okay? And so, but the problem is, if you notice here, depending on the organization, the larger the organization, the often they typically don't even trust the endpoint. And the reason they don't trust the endpoint is, in many cases, QoS is not even enabled on the OS to start with. But if you go through the configuration of it, enabling it, it's not that hard for the user to enable QoS for BitTorrent. Or let's say they've got a favorite gaming applications. They can turn that on pretty easily. So what they've done is, in many networks, they'll actually have the access switch on the data VLAN remark everything to priority 0, except for specific ACLs. So they've tried to, and I'll show you that in here then. So what they've tried to do is identify how I can detect that application, and that gets very brittle programming these ACLs. And in the Cisco Call Manager, you might say UDP port 8000 through 8080. But Lync uses the entire port range by default. So it becomes a lot trickier in the Lync environment to reconfigure the Lync voice, whether it's desktop or it's Lync conference calling, or if it's Lync voicemail. They can use different port ranges. So you have to get that set up. And then you have to make sure they don't overlap with Lync Video and Lync Desktop Sharing. So if you got those configured, now you have to make sure that those policies map between the policy group server with the switch ACLs in the switch. And those are two different groups, so the likelihood of something going wrong is pretty high. So because of that, in a lot of cases, I've seen a lot of organizations, especially larger organizations, say, screw it, we're just going to remark the data traffic to nothing. And now that's the root of a lot of the problems of that QS. So you know, either the network elements are misconfigured for QS or the network policies just simply remark the untrusted traffic to best effort.
Could I add to that?
Yeah.
Too? So I want to back up a little bit. So this is a very key point. On this story, I want to back up, is that basically this model is the old model of IP telephony or voice over IP. And what the key point is that you have a separate handset, and all it does is spits out voice packets. It's put its own VLAN, and it's secured more than likely with 802.1x. Okay, so that no other user can get on that VLAN and to denial of service it or try to put higher priority. Remember what I taught you about the EFQ? The ingress must be less than the egress. So they have provisioned this very carefully, the administrator, to put in its own VLAN to make sure the bandwidth for that class is set correctly so that it doesn't exceed it. So pretty well end-to-end, it's emulating a wire, and you will not get drop packets. So voice runs very well. And this is a typical VoIP deployment model. And everybody in the internet working world will tell you this is how you should deploy VoIP. Okay? Now, for the data terminal, again, don't trust it. Remark everything to 0 because we're not going to put you on the voice VLAN. So you have a voice VLAN and you have a data VLAN. So that's, go ahead.
Just a quick question on that. The VLAN, I understand that it has been done, but isn't that a VLAN was done because of usually the Cat6 capabilities, because the LAN usually is running X amount of Mbps, but now is it moving towards gigabit capacities and all that? This becomes slowly this starts to become more
But remember, you're talking about gigabit in the LAN, but you have branches, you have Wi-Fi, so this applies end-to-end. So I make a simple model here, but we're talking in the branch side where you might have, T1 line. These will apply. Wi-Fi is a shared medium. So this is being, if you go to any deployment model for
let me add on to that as well. So you're correct. In the core of the network, in many networks, there's not a big problem. Then the WAN and the Wi-Fi is the biggest issue. But in many networks, you also have a 10 gig link coming in, you have a 1 gig link coming out. And the way TCP likes to operate is it tries to get the data from one end as fast as to the other end as possible. So anytime you have a link speed mismatch, and pretty much every network you have has a link speed mismatch, so from 1 gig to 10 gig or 1 gig to 100 meg, and at that speed mismatch, the switches themselves in here have finite packet buffers. Memory has to be very high-speed memory, and we only have milliseconds of buffering, not hundreds of seconds, right? So what happens is, because of that link speed mismatch, it might only be an average utilization of 5%. So if you use a monitoring tool to look at your network, you might come back and say, I have no congestion on my network because it's only a 5% utilization. But if you look at the very small level, you'll get these microbursts where the network might hit near 100% load just for very short periods of time. Just enough to overrun that short queue that Pascal was showing there. And as soon as you overrun that queue, you've got packet loss and you've got intermittent audio quality issues. And at that point, you're likely to have multiple back-to-back packet losses. And Lync is very robust to random packet loss, but it's not good to losing, say, 3 or 4 packets in a row. So that's why even on a network where there's plenty of bandwidth, sometimes it's the TCP application of that same user because that PC, in reality, the PC is plugged into the phone and you're on the same link. And I don't know if you've ever been on a presentation or a webinar and then you download a PowerPoint. Sometimes that act can introduce an audio quality issue.
Yeah. So,
but good question. That's a common question I hear from customers.
Yeah, flash congestion is definitely an issue, what you just described. So the thing about I want to bring up on this slide about UC is that, you have the idea of two major things happening. You have these UC applications are spitting out voice video data on the same interface, so they're multimodal capabilities. And on top of it, they're moving. more and more devices are moving. They're on Wi-Fi. They are now able to move. They're not attached to a desk with a piece of wire. So that's even more problematic. Okay, so this is really what's going on. This is really the reality of what's being deployed. So you want to cover this?
Sure. And kind of like I was highlighting before, some of the problems is you've got two different groups trying to deal with those policies. You've got the UC or application guy making sure that there's policies like, do I have DHCP enabled on my endpoints? Do I have locked down the UDP port ranges appropriately in the archive server? Have I identified the right sites? Have I defined the right Erlang models? And on and on. There's all these things that the UC administrator does, and now it's kind of a sneaker net policy. It's handing that off to the network guy, and we know 60% or more problems tend to be human-introduced problems. And all it takes is this UDP port range to be swapped around. Or numbers transposed. I can't tell you how many times we've wasted time troubleshooting something only to go, you had that backwards. And I'm a pretty smart guy. This is the kind of stuff no human being ought to be doing. This is like machine programming. You ought to be doing high-level policies and engineering your network. And similar, like, the network guy has to identify where the traffic classes, what UDP port ranges map to what ACLs on the right switches. Does that map to my WAN policies, to my service provider? So on and on. And you have to do that across your entire network. It's things that people could be spending their time much better at. So I'd like to transition to kind of show you a demo of the proof of concept that we've done.
The UCNC SDN application automates network policy in a dynamic fashion, unlocking the full potential of unified communications and collaboration solutions through an enhanced user experience. Take, for example, two employees attempting to collaborate via Lync using application sharing. On the top left, we have the user James, and on the bottom left, we have the user Linda. James initiates a call to Linda and then starts sharing an application. As you can see, Linda's user experience is significantly delayed and not synchronized with what James is sharing. This is not a problem with Lync, but rather an issue with how the Lync traffic is handled across the network. This poor user experience is all too common with today's UCNC solutions. In fact, users are not only frustrated by this, they have come to expect this type of experience as the norm. The reality is that poor application performance is a drain on productivity and limits the power of unified communications and collaboration solutions. On the right-hand side of the screen, we have the HP UCNC application in a disabled state. When we enable the application, the user experience is instantly transformed. Now both users are seeing virtually the same information at the same time. The UCNC SDN application has taken call intelligence from the Lync server and used it to implement open flow rules via the HP Virtual Application Network's SDN controller.
So let me kind of drill down a little more from what the demo's doing. But like I said, we've gotten such strong feedback everywhere we've taken it from people going like, oh my gosh, we needed this years ago. Why aren't we doing more of this? And what's exciting is actually once they start understanding how the architecture works, they're coming up with additional ideas and things we hadn't even thought about in new use cases, what we can do to SDN to even automate that further. But as James is calling Linda, Lync server is part of the signaling. So even though the signal is encrypted and the signaling media may not even flow the same path, the Lync server has all this information. And then via this RESTful API, it's sending that to our UCNC SDN application. And that application now talks to our virtual area networking SDN controller, which knows topology. It knows where the switches are. Lync server knows virtual information. It knows IP addresses, and it knows what the users are trying to do, but it didn't know where they reside. It doesn't know how much WAN bandwidth or how much network bandwidth is between them. But our SDN controller knew the physical topology, but was lacking the virtual information. It knows IP addresses. It knows MAC addresses. It knows topology. It simply doesn't know what they're trying to do. And by bringing those two together, we're now able to, via OpenFlow, instantiate QoS rules, but only in those 2 switches closest to the end users. So we dynamically apply the policy and then can tear down at the end of the call. And so that ensures it's kind of a trusted model. It's automatic, no user configuration required, and ensures now that the marking is properly set throughout the network. So the rest of the network can continue honoring the way it's been provisioned. And the reason we're doing this instead of a complete end-to-end is because greenfield simply doesn't exist much outside of the data center. We've seen greenfield deployments in the data center, but in the campus and branch, people are not typically replacing the entire network. And so they want a way of how can I start using SDN without completely transforming how I've done things today. Okay? So the important part is how can we use SDN, right? SDN ultimately will replace the routing protocols you highlighted. They'll replace things like OSPF. But why redo your network to get the same functionality as we have today? As an example, VoIP was great technology, but at the end of the day, did it give you any more functionality than your legacy PBX? Not really. It was a platform. But the benefit got to be on this additional functionality we can provide. So what we want to do is use SDN to provide incremental functionality. It's really hard today to get customers to start embracing SDN. So one of these use cases is automating QoS. Another use case that we want to do that we're demonstrating and we have running in a couple customer sites is running security. So we're running IDS, IPS at every access port. Similar, we see that helping NAC. Another use case that SDN is really powerful on is using it for remote packet capture. So now we know where the users are, but in the past you had to actually go out and carry a probe or a sniffer or something on the port to see, okay, what's going on? I know where the problem is, I don't know what the problem is, right? Now what we can start doing is, I call this the button chair syndrome. The network engineer doesn't want to get up, he just wants to be able to troubleshoot the problem from where he's sitting. They can now be very proactive with this SDN solution to start in a hybrid model. And as they start becoming confident in how the solution runs, they can start then running and rolling out more SDN over time. Because today, it's new for a lot of people, and they're going to be leery to having it automate everything. But start small and build from there.
Excuse me. Just a question. So is this application kind of overlapping into the network monitoring application?
It's a great question, and I'll touch on that a little more. Because like we highlighted, we get 2 events. One is we get the dialogue start and end, and I'll walk through that a little bit, and then I'll hold off your second question about the network monitoring, because to me, having a great performance sports car without any dials is like crazy, right? How do you know you're breaking the speed limit? How do you know you're not overheating the engine? You need to have some feedback on what's going on. So they're both critically important.
But it's also doing the self-healing kind of.
Not today.
Not today.
Not today. We need to build more infrastructure in place. Most of the network engineers I talk to are not ready to have the self-healing working today. They don't even, they're still leery, like, show us that this works. So kind of here, I want to drill into the next level of topology. So we've got kind of a data center over here. We've got a core network. We've got some branch office. And the common question I hear is, okay, I get it. I see how you're using SDN to mark the QoS at the access layer, but isn't the WAN the biggest bottleneck? Well, most WAN routers have QoS enabled on them, and the mapping of that is which DSCP code point goes into which priority queue. The challenge was recognizing the application and making sure it went in that queue in the first place. So by marking it at the ingress, the key is you want to mark it as close to the end user as possible. Okay, as close as you can, and then simply keeping a consistent policy throughout your network. If you do that, you're going to have the best experience, and try to minimize how many times you change that, because usually that's where your problems arise. So here's the dialogue start. We've now set the OpenFlow policies to remark it at the closest switch, and only these are the ones that need to be SDN enabled. And they're only SDN enabled in a hybrid model for some functionality. Okay? And then what we do is, because they've now remarked the traffic, this is now what the traffic flows like. Ingress from the PC to the first hop is still potentially mismarked, but then the rest of the network now is all expedited forwarding, and even egressing back to the PC is now marked correctly. Any questions about that? Okay, and then at the end of, yes?
Sir, I probably missed it at the beginning, but the OpenFlow, is that a way of, like an API then, to dynamically set or programmatically set the QoS policy.
Yes, a good point. And as an example, today we have SNMP and standard MIBs for things, but QoS was never a standard MIB. So every vendor has varying SNMP proprietary MIBs, and even if you look at a Cisco architecture, depending on if you're in a 6509, you have to know which line card you're using. And you have a different MIB for every line card. So there is really no standard even today for QoS to try to push this. If you wanted to do that, you'd have to know what model of box you have and which proprietary MIB you need to set. So what we're doing with OpenFlow, we're using flow tables in the ASIC. And these flow tables basically look at the end tuple, and they can apply actions on it. And these actions can be things like drop. They can be modify. So the one action, we're modifying DSCP header value and changing that field. Other actions could be mirror. So for remote packet capture tool, you would mirror copy the packet. So there's a number of different actions we can apply via OpenFlow.
But it has to be, the switch itself has to be OpenFlow compatible.
Exactly.
And when did those start showing up?
Well, we were the first vendor to commercially ship an OpenFlow switch. So we've got 50 miles of switches now that support OpenFlow, and we've got over 25 million ports deployed, largely because we've been working with universities like Stanford early on and saw this technology compelling. So we put some of these hooks into our ASICs. There's a lot of commercial industry chips that don't support them yet, but you're going to start seeing more and more vendors are now seeing the benefit and how compelling OpenFlow is. The thing you have to look at is just because a switch says OpenFlow, there's a number of extensions inside OpenFlow. So are they the right extension, and do they have the right functionality? Some vendors only support a subset of the OpenFlow policies. The important thing is this is actually using a QoS policy that HP drove into the standards because of some of our work we saw and how important we saw that as part of one of the OpenFlow extensions. Initially, we started it as a proprietary extension. Well, our model is anything we can, let's get it into the open standard and drive adoption. And so the important thing now is the network is truly link aware and is enforcing trusted per session dynamic policies. If a user tries to have their BitTorrent application or any other application that are running at a higher priority, that switch will simply do the opposite. If it's coming in as a green, we'll mark it as best effort traffic and treat it as such. So there's no way a user can hijack that.
So since Lync is multimodality, right, and how would you differentiate between, this is IM presence, UM traffic versus live voice?
Yeah, very, very good question. As part of the dialogue event that Pascal was talking about early on, we know the users. We know the, is it voice, video, and data? We also know the bandwidth that they're trying to apply. So it's a lot of powerful capabilities that we can use, not just for the QoS, but even going forward. There's more and more use cases that we're looking at, and we're prioritizing which ones do we start next to build onto that top.
Even if the group policy for the PC is not set correctly, and it's not checked correctly, the SDN will take care.
That's right.
Yep.
I think that's fundamentally one of the key points is that what you show here is that you don't even have to deploy any QoS policies on even Lync now, server or clients. Because in this model, no matter where, given that the access layer of your network is all this OpenFlow or enabled SDN, when the user moves, it doesn't matter because we'll know the session is this IP address and so on, and that will be mapped from the controller to what port and switch that belongs to, what AP, and so on. So it's a very powerful model of just automating quality of service, period, in the story.
And even more importantly, you might, as an enterprise, be able to enforce QoS on company-owned devices, but the policy, BYOD, we let the cat out of the bag. It's not changing. So as people are bringing in their own tablets, their own cell phones, their own mobile devices, many of them do not even support the QoS concept. It doesn't exist in the device. And even if it did, you might not be able to control what it is, but you'd like to be able to provide this user experience. Michael?
The EF packets that you're showing in the wide area network, are those following a fixed path, like a label switch path, MPLS, or is it just traditional EF packets, routed packet by packet?
Today, it's how your standard core network would run, because what we're trying to do is start with SDN in a hybrid model. We know we can't change the world overnight. So, where's the easiest, lowest risk point to start to show some real value and then get customers to embrace more and more SDN. But having that actually work to do dynamic policy-based routing is a very powerful use case, because today, more and more enterprises are starting to say, hey, I need an MPLS network, but I also want to get a wide area network and just get a DSL link, which is cheap. But how do I dynamically steer link over one, but file sharing over the other? Complex policies today. You have to, because they're the same endpoint, the same IP is doing both. But how do you know which is what? This now allows the SDN controller going forward to do this dynamic load balancing of application based on a importance of that application that a user or the administrator would apply. So I think that's, there's a couple of really compelling use cases that we want to drive into this.
So when does this API kicks in? Is it like when this early media connectivity happening, or when?
Yeah, right at the ICE negotiation, so there's an invite, right, and there's this ICE negotiation that happens, right, and the candidate list gets paired, and there's a whole bunch of candidates. So early media starts up, and they do a media ping to find, if it's actually got connectivity in this prioritization.
Yeah, because Lync also has a capability that if it's doing the call, it might change. It sees that there's candidates that call, but then it might flip to other candidates saying, hey.
But they'll do a reinvite.
We would get another update, so we might get.
So you're kind of based on an invite, the final invite it comes and says, these are the candidates, this is now I have to make sure this is the US policy and to apply. These two routers are.
Mostly correct. So yes, in that case, but you might actually do a transfer of a call during a call. In that case, we would get an update policy. We terminate the first one and start a second one up. So
that's why we
handle
have
both cases.
Yeah, in the API we have a thing called update, not just start a session or start a dialogue. We got updated dialogue there.
So this is what you call like a hybrid deployment, where
Yes.
you OpenFlow enable the edge, but keep the core
Yep.
legacy.
Yep.
And this
And
could be Wi-Fi
you
too.
only need to start in a couple of branches, for example, and you'd start getting the benefit. And you could continue using the current mechanism you're using in the other sites, or you might not even be using any QoS, but at least you're starting to improve your process. But I think that's the important thing. How do you start small, right? Same with Lync. Nobody starts saying, I'm going to rip out my PBX overnight and deploy 30,000 new seats. You start small, gain confidence with it, see how it works, and then migrate that over time. So really, we have auto QoS for Lync is secured, and this is running in a hybrid SDN model for ease of deployment and for reduced risk. Because if something went wrong, we didn't break anything, right? You're no worse than you're off today. So customers are like, I love this. I get to see how it scales. I get to play with it. I get comfortable with SDN, and then start adding functionality onto that.
In that previous drawing, isn't the DSCP field is a layer 3 field? Right?
Correct.
But yet you're at layer 2 switch. You're marking that field.
Yep.
Is that right?
That's, yeah, and switches can do that. Most of the, not all switches, and that's why this won't work on a home consumer brand or lower end. You need an enterprise grade switch, but most of the switches these days are routing switches, and they can apply layer 3 policies both as ACLs or QoS remarkings at that.
Does it have to actually be in routing mode to do
No.
that?
No.
So it can do it
No.
as a pure layer 2 switch?
But that was a great question. You do not have to be in routing mode to provide this. And my recommendation in the last several years is focus on layer 3 QoS. Right? There is a layer 2 QoS and there's a layer 3 QoS, but I found that most of the QoS problems are because people try to do everything at layer 2 via 802.1p. But the problem is even between the PC, there is no .1p marking. Okay? Often between the switch and the router, there might not be a VLAN header. So whenever you lose the VLAN header, you've lost that QoS marking. And so you thought you marked stuff, and it just disappears. And then troubleshooting becomes a nightmare because you're using Wireshark. And I guess I dated myself there. So you're using Wireshark, but your NIC, depending on how your NIC is configured, you might not get the VLAN header. So it's really hard to diagnose. My recommendation is just try to use layer 3 end-to-end, and then use the .1p where you need it, because some switches simply just don't support the layer 3 functionality. But this is something we've been deploying even for our VoIP model now extensively.
Can the Aruba access points then also do the same marking if you're coming over wireless?
So we won't argue. I don't want to answer on behalf of them, but you should check with them. But I would believe yes. The point is that Manfred's right. Most of the, even their layer 2, they're layer 3 aware in context. So.
In Wi-Fi today, remember from a Wi-Fi endpoint, the only way for an application to give QoS is there is no VLAN on endpoints, and there won't probably be VLAN on endpoints. They are on servers, but not on endpoints. Is you need to use a DSCP, and that translates to WMM. So in Wi-Fi lines, they've got the translation from layer 3 QoS to the layer 1 to WMM code point or access category, which allows you to apply that over wireless access point as well. So where are we with SDN today? So we've got the most compelling software-defined networking solution. It spans both the infrastructure, it spans the control, and we're working with a broad system of application partners, including Lync, and we've got security applications. We're trying to show not just cool technology. I mean, technology was kind of like yesterday's thing about, hey, check out this new routing protocol, check out this new thing. We want to focus on business value, compelling applications, and then get people excited on how to deploy this. Our VAN, and we called Virtual Application Network SDN Controller. Our VAN controller has been shipping now, I think, last summer. So we've got that shipping. We've got an SDK, a developer SDK that we've created, and we're developing an app store. What we want to do is have a large ecosystem of partners add additional functionality onto that, because there's new things we have never even envisioned, but we want to have a standard way of how to interact with that and expose more value on that. In addition to that, we've got an extensive design and implementation and support services. So what we want to do is help educate people on how SDN use models, on how to start with SDN, and start from there as well. And I don't want to underestimate is, in many cases, you might actually have customers that have bought switches over the last 5 years that may not even know that they have this functionality in here. And something that I want to keep trying to remind people is there might be a subset of customers that are ready to embrace SDN today, but there's many that are like, it's still a little early. I'm going to wait a few months. I might wait 6 months. I might wait a year. But when people are buying new switches these days in the campus and branch, they expect 7 to 10 year life cycle out of that. Okay? So what is the likelihood, if you ask a customer, that they're going to want SDN over the next 5 to 7 years? I've yet to run into a customer that says, you know what, I'm willing to stick my head in the sand, throw money out and buying yesterday's model of switch and ignore SDN because I think it's just a flash in the pan and it's going to come and go. Most customers that I've talked to go, you know what, this is what I'm excited about this. I might not be ready to deploy full scale today, but I want to start piloting it. I want to put it in my lab. I want to start getting comfortable with it. So when they're upgrading and buying switches, they ought to be looking at switches that are open flow capable and can support this type of functionality. So from a path to SDN is something that, kind of reiterate, is how do you get to SDN in a manner that's cost-effective, doesn't cause a lot of risk, is we've got a tremendous amount of customers already. HP Network customers over the last 5 years, virtually all the products they've bought are now open flow capable, and going forward, the vast majority of products, at least managed products, are going to support open flow. And so even if they're running legacy core network, we can start supporting that functionality. And this really gives them investment protection, open standard, and there's no risk in doing that. The next phase is kind of what we did with this POC. Once we launch this application, they're going to start running a hybrid network and can demonstrate a real use case. And only they need to do is open flow enable, say, the access switch, or switch as close to the end user as possible. The problem is, as you get to, say, large core networks, the number of flows that might be running through that switch can be a high number. But on an access port switch, you've got 24 ports. How many link sessions can a user start? Okay? A user can only start so many sessions. Our typical switches can support about 4,000 unique open flow rules. So there's no risk of running out in, say, an access switch. But as you get closer to the core, these switches will need newer, more capable ASICs to be able to support larger numbers, or at least aggregating into superflows and doing that capability. So we feel the best place to start this is more towards the access layer and the distribution layer, and then rather having your core network be a super high performance, less intelligent network, and have the access layer provide that intelligence. And then going forward, we'll get to the point where we'll start having full native SDN domains, but that might be a certain enterprise within a certain data center, and they'll completely run pure SDN in the model, and what they'll allow you to do is full programmability, highly automated, and rapid innovation. But we're now at this stage here with hybrid SDN, and we're going to be in here for a while, and we're looking forward to getting here, but we want to be realistic and keep people running this before we push them too far around that SDN bandwagon. So kind of to highlight, by doing this optimized networks for Lync, we really truly are not just an application aware, but an application directed network that's working in concert between the Lync and the network to optimize the network. It helps eliminate the complexity of QS today, but going forward, things like call admission control, policy-based routing are things we believe that SDN is ideally situated to solve. As an example, if you have, CAC is possible to do with inside Lync. But if you have to share that same queue between, say, Lync and another video application, what do? Do you split it and give each one half? But then if nobody's using the other, you've wasted bandwidth. So today, the model we're using, CAC, is not scalable and won't work as more types of application that need to share that same behavior are grown. By doing this, we can truly ensure enterprise-grade voice and video. I guess the person that asked about the question left, so I'm not going to answer that one. But important really is multi-vendor open standards. We're driving this. We're demonstrating this with Lync and HP networking, but we really think the value is by having as broad of an ecosystem of partners and customers adopt that is going to be good to drive the adoption of this. And what we want to make sure is have investment protection built in for the next phase, because the hardware is always harder to upgrade that hardware than deploying a new software upgrade.
So I do want to leave, if we're going to hit the Q&A, I think we did a lot of Q&A already, but one thing I do want to say is that what you just saw is not only real, and unfortunately it's not shown at the show, but will at Enterprise Connect. And anyway, so I'll leave that at that. But the UCI forum, which the UC SDN task group, technical group, which I'm the chair of, and Manfred's editor at this point. So
and I'm also on the board of directors.
And board of directors, too. We've just closed on this use case. This use case is now, I think, 20-page document that's now closed and about to be signed up by the board, and it's going to go to the Open Network Foundation forum to build the API with the goal of, which I'm the vice chair of that end-user group at the ONF, to build the API by the end of the year, the actual standardization. So this is actually not future. It's not some science project. It's reality, shipping products with other use cases to follow. So we showed you the Quash use case. Right after we get the sign-off in March from the board, we'll start the next use case. And we're looking at things like traffic steering, traffic engineering, by class. We're also looking at things like for Wi-Fi diagnostics, security. There are many, many use cases. In fact, in the show, there was 3 use cases of sessions. This is the QoS one, there's a diagnostic one, and there's a Wi-Fi one. So if you get to see the other ones, you'll see how the same API, same framework, same structure, different use cases. So that's really what we're aiming to do. Again, the goal is to make the application, I call talk, program the network, Manfred calls
application-directed networking.
Directed networks,
right.
To be the politically nice and right way. So, any questions at this point? We took quite a lot during the session. Any thoughts? Go ahead.
So if, I have a lot of legacy access layer switches, right? And if the ASICs already support QoS, would it be possible to just do a firmware upgrade and then therefore now it becomes an open flow aware switch if the ASICs already aware of?
Well, I don't know whose vendor's equipment you have. Are you assuming maybe is a Cisco equipment?
Right.
Yeah. Unfortunately, they don't seem to be very motivated in keeping your current equipment running. So they've finally, after us really making a lot of noise and getting a lot of public awareness, have finally acknowledged that OpenFlow and SDN, that they were behind. About 6 months ago, John Chambers said, we missed this SDN transition and we're really going to start embracing it. But if you look at their strategy, they're saying, of course we'll support it, but you're going to need new hardware. Okay? They do not want you to keep your existing switches running. That is not to their interest. They want you to upgrade that equipment. So automating that in the current model is very difficult. Partly, in fairness, they probably don't have enough CPU cycles in their switches. They may not have enough memory to upgrade the firmware to put additional functionality. They have to rip something out. And innovating in this embedded firmware is very time consuming. So anytime we've added even the simplest feature, it takes us a year to come up with a simple protocol like LLDP Med because of how hard it is to put in there. The benefit now is by putting some of this SDN functionality and primitives into the switch, it allows us to innovate at a much higher rate. And once we're in that controller model, can add that functionality in months what used to take years.
That's actually a key point. Same ASIC, same instruction set, doing different scenarios because the application is doing it like a QoS application, truck engineering application, security application, all using the same kind of programming language, OpenFlow, same instruction set. I do want to remind you, we do want you guys to fill out the poll. This has been kind of cycling through while you were talking. There was a bunch of sessions, Lync Ask the Expert, I think at 5 today. We do want you to fill out the session poll, please, to get your feedback. It's really important. And
please do that. It allows them to decide, was this a valuable session? Is this the right level of contents? Was this too detailed? Did we not go detailed enough? They use this to drive sessions for next Lync Conference. So
right.
please do fill that out.
And then we're still here. We got 5 more minutes if you want to take any more
I think
questions.
we've actually got almost 10, don't we?
I got a few minutes.
Okay.
5. But anyways, we're also here afterwards if you want to talk a little bit. Any last questions? Did you guys think this was really valuable? Again, not future, this is reality, shipping or about to ship or whatever.
Can I use that with any switches or only with HP switches?
The first instantiation of the release we're going to do, we're only going to support HP switches at first because we want to get something out, something that we've tested and we know it works. But a follow-on release, we'll start supporting other OpenFlow-enabled switches. There aren't that many out there today, in all fairness. It's just a very limited number. And of the ones that say they support OpenFlow, there's only even a smaller subset of them that actually support the QoS extension. But as more and more come out, absolutely, it's to our advantage for you to deploy this type of solution. It gets to demonstrate our leadership. We don't want to exclude those other switches. We're driving the open standard for obvious reasons.
Any reason why routers could be OpenFlow enabled as well?
Let me go back to an early slide. Absolutely, and it's a very compelling use case. And so that is something we've already announced. We aren't shipping them quite yet. Sorry, right here. So we have announced, I apologize for the formatting in here. We have announced our we've got a very compelling series of multi-services routers, very competitive routers, both from a performance functionality standpoint, and some of them even support SBA modules. So they are media gateway, that's Lync 2010 and 2013 qualified as an enhanced gateway, but you can also put an SBA module in them if you need it to be a sort of survivability. And those same routers, we will be adding OpenFlow support on them so that some of these use cases we talked about would be compelling and things we could support, let's say in a hybrid model, only if you had HP OpenFlow-enabled routers on them. So there's some functionality we could do with that. And if you had, say, OpenFlow-enabled switches, there's maybe QoS markers we could do, but we could do some of the dynamic routing or some bandwidth management via the router. So what we're going to try to do is do as much as we can without the routers, but if you have the routers, it's even better, so better together. There's additional functionality we can provide.
But that 50 number, is those the ones that are compatible with this API that will work with the,
Yeah.
the SDN, or that's, because you mentioned not all were compatible with.
Well, these are HP switches, these 50 switches. Now, some of them are data center switches of those 50, and you're not likely to run this application on them, but they could.
Well, the application runs on today on the SDN controller,
Yes.
or runs on some machine. But it's the open flow rules that enables what it can be done from an instruction set, just like a CPU. What's the instruction
Well,
set?
like the 3500s have
The HP 3500s,
Yeah.
yes.
they would have that.
Yes.
And 3800s, and then, but probably the 29, probably not.
The 2920 is supported, right?
Oh, okay.
And that's a very competitive price product, and we've got between the ones you listed there, we've got a lot of customers with those deployed. And like I said, when we sold them initially, we did not think they could support OpenFlow. So we've added that after the fact, and are adding additional functionality because we believe in investment protection. That's how you build loyalty with customers. Yes?
Do I need to use an HP gateway if I want to have that cost?
No. We prefer you'd use our gateways, but it'll work with any Lync qualified gateway. Now, unless Young Ching puts a command in there that breaks it for you.
Did you have a question? So last question, I think, when we can take the rest after.
So for the HP SDN controller, you mentioned there's a SDK provided, so like a third party can leverage the functionality of that.
Yeah, and we've even done some workshops, a couple of workshops where we try to bring in partners and do some training and get them hands-on on what OpenFlow rules are and just get experience over the kinds of things you can do with that. So that was quite successful, and we're going to try to promote more of that. And because it's really the more we can get an app store with these types of applications in there will really drive that functionality. Just like Lync, one of the strong points of Lync is the entire partner ecosystems of the extensibility they added, because no way can HP and Microsoft come up with all the use cases we can think about, but some of these partners are very focused on specific use cases. So somebody came up in the hallway just today and said, could I use this for call recording? And I go like, yeah, actually that would work really, really well. We could go back in here and program a rule that says in here, mirror only that flow that I'm trying to record to an archiving server. And that archiving server or call recording server wouldn't even have to reside in the branch, because if we're not recording every call, now if you're only selectively recording certain calls, that bandwidth isn't that excessive. So there's some very unique things we can start doing based on that capability that somebody might not even have designed into the product up front.
So I do want to say we're going to cut it off here, but any more questions, we'll take them here. One last statement I do want to make is that, again, what we're talking about is what my senior management says. We're actually bringing internetworking. SDN's bringing internetworking into the 21st century.
Yep.
From 30 plus years of being stagnant, we're actually moving into a proper, modern kind of information system. The second thing I'd like to make a statement is UCSDN is actually a paradigm change. UCSDN is about applications programming networks, or as Manfred would say, instead of programming networks,
Application-directed networks.
directed networks. So,
And also, I do have, we got a repeat session tomorrow of the same one, so if you've got some colleagues or people you think that would benefit from that, please bring them by. And then also tomorrow, earlier, I think 10 or 11, I've got a session where I drill a little bit less on the API, but I drill more into the OpenFlow and the use cases around that a little bit more. So if you guys want some more deep dive into that, please do stop by either of those sessions.
okay, thank you very much for attending. Have a great night.